afternoon, everyone. I welcome you back to the Doctorate class. This question is Jamb 1995. It's one of the simplest topics we do in physics for those of you in SS1, which is the same thing as grade 10. You learn this under dimension. Dimension is very interesting, very simple if you understand how to do it. If you are not used to doing dimension, don't worry. By the time we are done with this, you see it is very, very simple. All you need to remember is your multiplication, division, and small indices. Now let's go. Which of the following is the dimension of pressure? They gave us options A, B, C, D. Now when you look at the options, you see they're using letters M capital, L capital, and T capital. Why? Because in dimensions, capital M represents mass. Capital L represents length or distance. It could be breadth, it could be height, it could be displacement, it could be distance, it could be radius, it could be diameter. Any distance is represented as capital L under dimension. Any time you are dealing with under dimension, you represent it with capital T. And that makes it easy. You know why? Dimension is expressing derived quantities in terms of the fundamental quantities. You know there are 7 fundamental quantities. The first basic 3 are mass, length, and time. I'll repeat this again, very important. When you're doing dimension, wherever you meet mass, you write capital M. Wherever you meet length, you write capital L. Wherever you meet time, you write capital T. Now the question is, find the dimension of pressure by yourself and check which option is the same as the one you got. Now let's do it together again. In physics, we know that pressure is force over area. You are the one to remember this because they didn't give you the formula for pressure. So you simply have to remember the formula. So pressure P is F over A. This is the same thing. Remember, in physics, force is mass times acceleration, then divided by area. Right? Just take it easy. This is P equal to M times acceleration times 1 over area. You know that is the same thing, right? So we see mass is simply mass. So just leave it where it is. Remember that acceleration is velocity divided by time. Then multiply by, of course, 1 over area here. Now, you can easily change area as length times breadth. It's the same. Just break it down until you remove all the derived quantities from this expression and replace them with any correct basic quantity. Mass is a basic quantity, I won't change it. Times velocity is a derived quantity. Times 1 over t. You know that v over t is the same thing as v times 1 over t. So that's all I've just did. Times 1 over length times breadth. Okay? Now let's continue here. Pressure equal to, this is over 1 over 1. Mass times, remember that velocity is distance over time. Multiply by 1 over time. I'm just lifting this one. next thing. If you check here now, I don't have any derived quantity here, so I'm good to go. Everything here are all fundamental. During dimension, what do? Wherever we see mass, we change it to capital M for dimension, M over 1 times any length we see, capital L, over any time we see, capital T, times 1 over time here, capital T, times 1 here over length, capital L, times breadth, another length, capital L. Now, what do we get? There's only one M on the numerator. We write it. How many L's do we have on the numerator? Just 1. I can just put it 1 here for sake of clarity. This, any number multiplied by 1 is 1, so we're done with that. Now, 1 times T is T. T times another T means 2 T's. It means T raised to power 2 times 1 L times another L means 2 L's multiplying each other means L raised to power 2. What do we do now? Small indices. There's only one M on the numerator. We just write it down. There is L in the numerator, L in the denominator. So we take one of them, write it down. What is the power of L in the numerator? 1. In indices, division means subtract for the indices. What is the power of L in the denominator? 2. Then there's another letter here, T. It doesn't appear on the numerator. That means it is T raised to power 0. Since it doesn't appear here, it means T. Let me just put it for sake of clarity, but it's not supposed to be there. Sorry, you understand. It means T raised to power 0. Division means minus. What's the power of T in the denominator? 2. So we have pressure equal to, there's 1 M. Remember, this means M raised to power 1. Then we write L. 1 minus 2 is minus 1. We write T. 0 minus 2 is minus 2. Of course, a number raised to power 1 is that number, so we can easily remove this 1 here. And this is the dimension of pressure, AGIA. Now, AGIA, what is left is, now your answer, you've gotten it, and you know you are very correct. Go to your options, check which one is the same as your option. Option D is not what we have here. Option C is not the same thing as what we got. Option B is not the same because our L is minus 1, while here L is plus 1. Option A, our M is 1, their own M is 1. Our L is minus 1, theirs is minus 1. Our T is minus 2, theirs is minus 2. So A is the correct option. I hope that makes it very easy and simple. When you're dealing with dimensions, guys, don't omit the steps until you become so good. For those who are in SS2, SS3, it's easier for them to jump some steps here to get their answers through. But for you, a beginner, take your time, break it down until you've mastered it. You can easily, cut out some steps and you get your answer. Thank you. I hope this helps you next time.